So before we build these value and reward distributions, first we'll have to extract the different unique values of these of the various components of our states, like the segments, months, month period, days. Because why we are doing this is because we'll see in the next code block that we'll be building some iterative loops around these components before we extract the information which we want. So let's extract these information. So it's just we're just taking the data frame, which is reward full, and then the segment and its unique values. So similarly, all the other values are also extracted. So let's just implement this, and this is the output which you got. So segments, the unique values are Q1, Q2, Q3, etc., and months, month period is 0, 1, and days, all these days of the week. So these are our unique values of this. Now what we will do is we will also define some dictionaries, because all these values of different the value functions and the reward functions will be storing as dictionaries. So and therefore we'll first define these dictionaries. Now first dictionary is the count dictionary. Now this is to store the count of the products. Now if you remember in our simple averaging method, you had this it was based on the number of pulls of a particular lever, because you had to track the number of times a lever was pulled. So similarly, in this context, each of your lever is a product which you recommend, and therefore we have to take count of the number of products which have been recommended. So that's what you have your count dictionaries also. And similarly, the second dictionary is the value functions, value distribution. Based on the updates that new estimate is old estimate plus the step function into reward minus the value function, the old value function. So that is what we use for this dictionary is used to store those values. The third one is the reward dictionaries, which, as we said, like our non-stationary reward distributions. This will be again a non-stationary reward distributions, and this reward distribution would be based on a Gaussian process, like what we saw in Post5. So anybody who have doubt, please refer Post5 of the videos pertaining to Post5. The last one is about recommendation count dictionaries to keep track of how many times a particular product was recommended. So that is what this dictionary is for. So let's implement this, or just so all those dictionaries are created. Now we will start the initialization process for reward and value function. So it's I know it's an ugly looking loop, but let's understand it. So here the first hierarchy is the segment. So we go through each segments, and for each segment we go through each of those months, and for each of the month we go through each of those periods, whether it is before 15 days or after 15 days. And for each of the period we go for each of those days. So that's the 4 hierarchies of this. So what we will do is, first we take a subset of this data based on these specific states which we have, that is part of the segment, month period, and day. So the first is you will get a data frame, pandas data frame, a subset for those period. So next we will check whether that subset is greater than 0. So only if the subset is greater than 0, there is data in that. So we'll create, in the next line we'll create a state ID. So a state ID, just to track the state, we create a state ID which is a combination of your segment. Anyway, since the segment is we will convert into a string format as a segment, then underscore the month, then the period, again it's a numerical value, so we are converting into a string, and then last is the day. So all the combination of all these things will form your state ID. Now we initialized the count dictionary, right, earlier. So count dictionary and for each the count dictionaries, each state ID is a specific record. For the state ID, then we'll create an inner dictionary also for that. So what are we going to use this inner dictionary? The inner dictionary is to store all the specific products, so for example, under that state ID, under this combinations of segment, month period and your day, we are going to look at all those products, specific products and their quantity. So the keys for this inner dictionary would be your the stock code of the product, and the value of the dictionary would be the quantity. So that's what we are doing in the next line, which is we are iterating through the complete set of all the products which has been bought for that specific state ID. So and then we are storing it in the count dictionary, in the inner dictionary. So the outer key is your state ID, which we have created, and for the inner loop, inner dictionary, the inner dictionary's key is your stock code. Okay, so your stock code, and the value is the quantity. So this is how we'll do. So let's implement this. It will take some time before it runs based on your speed, and then we will see the values of this, or we'll see the outcome of this dictionary. So we have completed that run, and let's just look at the count of this dictionary. So the count of this dictionary implements the number of states which we have. That's the number of combinations of segment, your month period, and your days which you have. So we can see that there are around 572 different states which has been formed. So let's look at one of the state ID. Let's say state ID of when the segment is Q4, month of September, first Wednesday, this is after 15th. The date is after 15th and a Wednesday. So here, so that's the state ID, and then going to the count dictionary and giving that key state ID, you can get all those products which is listed down. So as I said, as we discussed, the count dictionary and the key state ID will give you another dictionary whose key value is your product code, and the value is the quantities or the number of quantities, these number of quantities for this product. So it indicates the frequency of buying for this product. So this is so we'll implement this, and this is the output which we get for this specific stuff. So you can see the product code and the counts for this. So far we have extracted the counts of the products based on the states which we wanted. Now what we will do is we will initialize the value dictionary and the rewards dictionary. So now both these value dictionary and the rewards dictionary, instead of, as we said earlier, instead of just initializing with 0 values, we'll use the current buying frequencies as an indicator, as an initial values for this. And later on, once we'll see that during the self-learning process, as and when these products are bought, it will align to the specific state and the specific buying frequencies of these products, but these are just initial values to start off with. So let's look at how we implement this. So we'll take an iterative loop for all the across this count dictionary keys. Now count dictionary keys, these keys are the states. So each key is a state ID. Now we are iterating, you are taking each of those state IDs, and then what we do is we look at another dictionary. You take the inner dictionary, which is your product counts. We store it in product counts, because the count dictionary and the state ID will give you a inner dictionary which has the product count as the key and the quantities as the values. And we'll initialize two more dictionaries, because we have created these dictionaries, the policy dictionary and reward dictionary. Policy is your value dictionary and your reward dictionary. So each of these dictionaries, according to its the key is your state ID here, and each of them will create inner dictionaries also, because in this inner dictionaries we will again store the values of as a key you will store the values of your product code, and as the values you will create the quantities which has been bought. So these two will initialize, and then we'll have another inner loop wherein we go through the inner dictionaries, which is your product key, which is your product count. Product key is your product counts, the product stock codes, and we go through each of the stock codes, and then we'll store use the values or the quantities in a Gaussian process. So let's see that. So in this line, the first line, you take the policy dictionary. The first key, the state ID, is your first key, and for that inner dictionary, the product code is your next key, and then the values are generated through this Gaussian distribution. That is, it is centered around that value. The quantities which is for each of this product is your mean. That is centered around it, and then you have standard distribution of 1, and then you generate a random distribution, random number, which is centered around that mean value, mean of the amount of quantities which has been bought. So both the policy dictionary and the reward dictionary, we update these values or get those values. Let's run this and then look at the output. So these are the outputs which we get for this. Now let's look at this policy dictionaries, and for a specific state ID, let's look at that state ID which we have earlier defined. And so this is the the initial the first few products and its values. So now you have these products and its distribution, Gaussian distribution, which is centered around its quantities. Now what is the significance of these from a recommendation perspective? So here the intuition is this. Now we have created the value and the reward dictionary based on the number of times these products are bought. Now since these products are bought, these frequencies in which the products are bought indicates its popularity. So we want to when we recommend some products, we want these the recommendation engine should recommend the products which are more popular among that specific state. So that is why. So this mechanism of creating this initial values is based on looking at products or ranking these products which are more popular among for that specific state IDs. So that's the whole premise of creating these Gaussian distributions and creating these dictionaries, because this will form the basis of your later recommendation. So it's a way of ranking these products, and the rewards also, the rewards also gets generated based on the same process. So that's the rationale for this.